Alrighty, so chapter 1, section 1, after you did matrices, variables and expressions. There is no vocab for this section, nothing I'm going to be quizzing or testing over, so you can go straight into the book examples, which is this. So let's go ahead and get started talking about it. Writing expressions with addition and subtraction. So we're going to talk about variables and expressions. Obviously, a variable is that, I'm going to actually pop the definitions just so you see them, but I'm not putting those in your packet. So these are right in your book on page 4 in the paper book. I'm pretty sure that's right. Mathematical quantity is anything that can be measured or counted. Some quantities remain constant, others change or vary and are called variable quantities. That's where the term variable comes from. Algebra uses these symbols, right? A variable is a symbol that is usually a letter that represents a value of a variable, quantity. An algebraic expression is a phrase with no equal sign, right? So it's like x plus 3, 5 plus y, things like that, or x plus y. Numerical expression is just things like 2 plus 4. So it's just numbers, no algebra involved there. So back to the matter at hand as we're discussing this, write an algebraic expression. So again, there'd be no equal sign with addition or subtraction. Write an algebraic expression for the word phrase. So 32 more than a number n. So to get more than something, you're obviously going to add on. So 32 more than will be n plus 32. 58 less than a number. Now here's where we got to be careful. 58 less than a number n. Does that mean we subtract the 58 or the 58? I'm sorry, 58 less a number n. I almost messed that up, didn't I? 58 less a number n. That means 58 minus the n. If I say 58 less than a number n, that would mean I'd have n minus the 58. So you got to be careful of the difference there. Watch the words. I almost read a word that wasn't part of it there. So 58 less a number n, not 58 less than a number n. Okay. So we're going to write an expression for 18 more than a number n. So that's n plus 18. Now please do note you also could obviously have 18 plus n here because we know that addition is both commutative and associative. So we can commute it and move it all around all we want. So that's what we're looking for there. Second example out of your book here in chapter 1, section 1. Write an expression with multiplication and division. Notice again we're still doing expressions. So you won't have an equal sign. 8 times a number n. So it's 8 times n. A whole bunch of ways to phrase that. Now remember, if we're using a variable and we're not using the multiplication symbols, 8n is acceptable, not n8. So I don't want to see n8. Now if you had n times 8, that's different. But since it's algebra, we like to write it n8. And remember, variables are lowercase. That's something I know you covered last year. The quotient. Quotient means division of a number n and 5. Quotient. So we've got n divided by 5, or n divided by 5 using the fraction bar. So, got it 2. What is an algebraic expression for each word phrase in part A and B? So 6 times a number n, we're looking at 6n. Again, since algebra, let's just write it the algebraic way. Let's just do that. The quotient of 18 and a number. Now this is where order matters. 18 and a number. That means the 18 is being divided by the n. If I said a number in 18, you'd reverse it. It'd be a divided by 18. So in this case, again, algebra, using the fraction bar, 18n. And then C, do the phrases 6 less than a number and 6 less a number y and 6 less than a number y mean the same thing. Kind of let that out, didn't I, earlier in the last one there? No, not at all. In fact, that's written out here very nicely for you in my answer piece. 6 less a number y means 6 minus y. 6 less than a number y, notice that, less than a number y means y minus 6. Really, really, really important distinction. Don't want to mess that up like, I almost did. Okay, we can also write expressions with 2 operations. That's fun, right? What is an algebraic expression? Again, no equal sign because we're doing an expression for the word phrase. So 3 more than twice a number x. So twice a number x, that's your 2x. 3 more than is to add 3 on. Now you could have also put in 2x. I made that word up today. You could have also put 2x plus 3. Alrighty. 9 less than the quotient of 6 and a number x. Now notice, 9 less than the quotient. The important part here is less than a quotient. So that means we're going to have a quotient. That's a division there. So 9 less than the quotient means the 9 is being subtracted. And notice again, 6 and a number x. That means the 6 is divided by the x. And then the product of 4 and the sum of a number x and 7. So product of 4 and the sum. So 4 times this sum inside of a number x and 7. So x plus 7, get a sum, 4 times that whole thing. Later on we'll discuss the distributed property. Fun with that, right? Alrighty. What is an algebraic expression for each word phrase? 8 less than the product of a number x and 4. So that means these guys are going to have a product. They're multiplied, x and 4. 8 less than that, so you get to subtract the 8. Don't worry, we're going to practice the heck out of this to make sure you've got it down. B, twice the sum of a number x and y. So twice the sum, so the 2 is not multiplied by the x until the 8 is added. Then the 2 is multiplied by it. And finally C, the quotient of 5 and the sum, so 5 and the sum of 12 and a number x. So we're going to get the sum down, and then 5 is divided by that. Lots of problems in this section. Let's continue. What word phrase can you use to represent the algebraic expression 3x? That means make up your own, right? 3 times, be real simple if you want to. And want to do this on my quiz? Yeah, do it, seriously, be simple. 3 times the number x. Or you get fancy and say the product of 3 and a number x. Alrighty, the sum of a number, so here's your got it's. What word phrase can you use to represent the algebraic expression? So here is the sum of a number and 8.1, or a number x if you prefer. This one, the sum of 10 times a number x and y. So adding that y on there, that's where the sum comes in. Or you can say 10 times a number increased by 9. Something like that might be kind of fun. I know you're thinking I'm a nerd. It's okay. This one, the quotient of a number n and 3. And finally, 5 times a number less 1. Or you could say the product of a number and 5 less 1, something like that, if you want to get kind of fancy there. The difference, right? That's another good word to use too. Here we go. You know I love them. Story problems. Write a rule to describe a pattern. Now that's fun stuff. That's what math is really about. Math is the study of patterns. Hobbies. The table below shows the height above the floor of a house of cards, depending the number of levels. Obviously, we're expecting the cards to be a standard height, right? What is a rule for the height? Give the number of words and use as an algebraic expression. So 2 levels, right? 3.5 times 2 plus the 24 inches of the table. So let's make sure we understand. Each card is 3.5, and the height of the table is 24. So 24 plus 3.5, that's 1 level. 24 plus 3.5 plus 3.5 is 2 levels. 24 plus 3.5 plus 3.5 plus 3.5 is 3 levels. You get the idea. So we can take a look at the pattern here. 2 levels, 3 levels. So we could even put the 1 level button if you want to, right? You could say 1 level, and you could say 3.5 times 1 plus 24, right? So that's kind of missing on there. 3 levels, 4 levels, 5 levels. So obviously the variable here is the number of levels. So that's where our x is going to go. So we start out with that let statement, or in this case they're using n. Let n, right? Let n equal number of levels. Okay. Again, do not forget that let statement. I'm pretty picky about that. I promise this is the letter L right there. So the expression you're going to write then is going to be this right down here. 3.5, that's the height of the card, times n, plus the 24 inches at the height of the table. So here we go, looking for a pattern in this one. Suppose you draw a segment. So by the way, we've got a hexagon here. A segment is a line from one vertex to another. Suppose you draw a segment from one vertex of a regular polygon. Little definition piece there. Regular polygon, by the way, means a polygon, that's right, a closed multi-sided figure that all the sides are equal in length and all the angles are equal. That's what regular means, not just any old regular. It literally is a definition. So but anyway, starting over, Suppose you draw a segment from any one vertex of a regular polygon to the other vertices. A sample of a regular hexagon is shown below. Use the table to find a pattern. What is a rule for the number of non-overlapping triangles formed? Notice that means they're saying that I can't go like this and this, so we're not overlapping is the idea. So, alrighty, and again, give the rule in words of an algebraic expression. The only thing I would argue here is that they're not including the let statement. We'll get to that though in a second. Number of sides of a polygon. So if there's 4 of them, right, you can have 2. So here's so the number of triangles. Here's the idea. If you had a square, right, draw 1. Otherwise you get overlapping. So we're not going to have overlapping. So it's just 2 triangles being gained there, right? Number of triangles is 2. 5 minus 2 is 3. So if I had a 5-sided figure, hang on a sec, we'll pop one of those in. Not too shabby for hand drawn. So 1, 2, so that leaves me with 1, 2, 3 triangles, right? And we can see that there's a 3 right there. 6, we know yielded 4 triangles, right? So we're looking for a, notice here again, these are included so that you can kind of see how the pattern fits in there, the minus 2. And notice here, right, 1, 2, 3, that's 4 sides, 5 sides, 6 sides. Ooh, n sides, right? So n minus 2 becomes our rule. Now again, we do need that let statement, so let n equal number of sides. That's important. Alrighty, so again, our expression is going to be n minus 2. Study of patterns.